All right, section 1.3, linear equations in two variables. So linear, we're focusing on just lines. So a quick refresher on the slope of a line. The slope m of a non-vertical line, so any line that's not just running up and down. So it could be a horizontal line, diagonal line, different slopes. If it's running through the coordinates x1, y1, and x2, y2, then the slope is y2 minus 1. So, m, they use the word m from modulo, which has to do with division, but that's not super important right now. Is m equals y2 minus y1 over x2 minus x1, and it specifies where x1 and x2 cannot be equal to each other. It's kind of like over explaining itself. So it says non-vertical and x1 and x2 can't be equal to each other because that would actually make the vertical line. Now, some examples of different types of lines. So one general form of a line is ax plus by plus c equals 0. To be honest, that's not a form we use very often. A vertical line is just going to be some value x equals a. So it's going to go through some x coordinate, and every coordinate on that vertical line is going to have that same x coordinate. So let me just draw a quick example of what that looks like. That would look something like this. Just a vertical line. Every x value on this line is the same. Now, we can also say the slope on that one is undefined. It doesn't have a positive slope, it doesn't have a negative slope, it just has perfectly up and down slope. It has no slope. It's undefined. I shouldn't say no slope, but it's undefined slope. Y equals b has a slope of 0. That one would be a horizontal line. The slope-intercept form, the one we're probably most familiar with, y equals mx plus b, where m is our slope, and b is our y-intercept, where it hits the y-axis. So slope-intercept. It's got m, your slope, and it's got your y-intercept, b. The point-slope form. That's as if you take your slope, you have m, and you take the coordinates of one of your points, x1, y1, or you could use x2, y2. Doesn't matter. You're going to end up with y minus y1 equals m times x minus x1. Last option, point-slope form, jumping ahead to two-point form. We're using all the coordinates x1, y1, and x2, y2. It's really the same as point-slope form. I think that's probably why I slipped up and said it, because the only thing that's different is instead of m, we have y2 minus y1 over x2 minus x1. That's just the slope formula. Everything else is the same. Okay, with all that in mind, let's give a couple of these a shot. It says, using the above formulas, answering the following questions. We're just going to focus on slope for these first 4. We're not going to do all of them. We're just going to do, I'm going to pick 3 of them. I'm going to skip letter C. We'll do A, B, and D. You can do C on your own. Check the answer key to make sure you did it right. So, again, if it's helpful to you to label the coordinates, please do. So I'm going to label this as x1, y1, and this one as x2, y2. And if we use the formula for slope, m equals y2 minus y1 over x2 minus x1, let's just plug in what we know. Y2, we said, was 1, minus y1, which is 0. Well, that'll be easy. X2 is 3 minus x1, which is negative 2. So 1 minus 0 is just 1 over 3 minus negative 2 is the same as 3 plus 2. So we end up with 1 over 5. So our slope is 1/5. Letter B. Again, I'm going to label these. And folks, if I go too fast, pause the video. So if you need to catch up and go back over letter A, pause the video, catch up on your own, rewind as much as you need, and then catch back up. This one, let's do x1, y1, x2, y2. And folks, once you get back in this habit, I know this is stuff that you've done before. Once you get back in this habit, you don't have to label these every time. I'm probably going to stop right after this one. So we got our slope, m equals, following that same equation we just used, that y2 minus y1. I'm not even going to write the equation now. I'm just going to do y2, which was 2, minus y1, which was this 2, over x2, which was also 2, whole lots of 2's, minus x1, which was negative 1. Cleaning up that top, 2 minus 2, 0. Denominator, 2 minus negative 1 is the same as 2 plus 1, which is 3. So we end up with m equals 0. Going back up over here, we had an m equals 0. That's going to be a horizontal line. So it's a horizontal line. I'm going to abbreviate it as horiz for horizontal. The equation for that line is going to be y equals 2. You'll notice the y values for both of these coordinates are 2. It's just going to be 2, 2, 2, 2, 2, 2, 2, 2, 2 all the way across. I'm going to skip letter C. Again, try that one on your own. You can pause the video now, check it out, check it out in the answer key. The answer for that one, by the way, is m equals -5. It's got a negative slope. Check the answer key for the work on that one. Letter D, we have m equals y2. I'm just going to assume that this is 0.2, this is 0.1. y2 is going to be 1 minus y1, which is 4, over x2, 3 minus 3. So we have m equals 1 minus 3 is -3. Denominator, 0 minus 3 is 0. -3 divided by 0. How many times does 0 go into -3? It doesn't. This, friends, is called undefined. It is undefined. You can't divide by 0. Now, it's undefined. If you go back up, you might recall up here we said, well, vertical line is undefined. Oh, sorry. Oh, you didn't even see it on your screen. My iPad got weird. But it's undefined. It's a horizontal line. No, sorry, it's a vertical line. I misspoke. And you'll notice the x coordinate for both of these is the same. So it's a vertical line at, well, x equals 3. So just a couple different types of lines.